Today, I will give a brief introduction of the working process of atomic layer deposition techniques, and also demonstrate how to deposit aluminum oxide films on silicon wafer. Now, firstly, I want to introduce every part of the machine and show how to use programming instructions by LabVIEW. Now, here's a chamber where the precursors are sequentially introduced in and build the atomic layer. And then open the door of the machine. The precursors are located at here. The first one is the water, and the second one is the precursor for aluminum oxide, which is the trimethylaluminum. And the third precursor is for titanium oxide deposition, and that is titanium chloride. And that's a reminder, due to the high saturation vapor pressure, we always need to set the temperature of this precursor up to 70 degrees centigrade. And the last one is dyed zinc for zinc oxide deposition. Now next we start to set the parameters. This is the software user interface that we need to. Firstly, we need to check whether this program is running. Look at this arrow at the left corner of the interface. It always should be blackboard, which means it's running, instead of the white color. And look at it here. This is a simplified scheme for heater equipment on chamber, precursor, and air-operated valve. In order to make the machine functioning properly and protect our system from damage, the temperature of the heater 7 should reach to 60 degrees, and the heater 10 should up to 150 centigrade before your deposition. If you want to deposit a titanium oxide layer, the temperature of corresponding precursors should always set to be 70 degrees. You can set it here. And then even when the temperature has up to the targeted temperature, that you can start your deposition. Here is the heater 8 and heater 9, which is for all the heater and center heater in chamber. And this temperature setting is also your reaction temperature for deposition. So you are recommended to read through some relevant materials for reference before you experiment. However, the temperature of the chamber in both heaters should always be at least 80 degrees. And also you can load the recipe from the recipe area in computer. Here is a cycle matrix, and you can program of the cycle recipe here. Just right-click this area and open a menu for aluminum oxide deposition recipe. And also you can edit the recipe parameters here, like the pulse time for the first precursor and the waiting time for the next precursor's pulse time. And the substrate is exposed to the first precursor, which reacts with the surface. And any unreacted first precursor is then purged out of the chamber. This is called a purge cycle. And then the second precursor is introduced into the chamber, and this builds another layer of molecules on the last layer. And then another purge cycle removes the second precursors from the chamber. And these steps combined are called a cycle that provide a multi-layer of the film. So these steps can be repeated as many times as designed to build the film layer by layer. And this area is flexible for you to set and determine how many cycles you want to complete, and to get the design signals of your experiment to the growth of a monolayer film. And next we can look at these buttons. And the first button is to stop the LabVIEW program. And the second one is to open and close the stop valve to the pump. And the third one is to control the on and off for all the heaters. Last button is for starting and aborting the deposition process. So here shows the nitrogen flow rate in chamber. This is the remaining cycles when starting the deposition, and this is the total runtime for your deposition recipe. From this graph, we can monitor the gauge pressure in chamber, and this graph shows the vapor pumps performance from the precursors. Okay, next I will show you the detailed operation to deposit aluminum oxide films on silicon wafer. There is a metal hood on the chamber that cause the chamber lid and the wall are very hot. So we need to use it carefully and do not place any flammable materials on and near the ALD machine. So firstly, we need to open the chamber to put the substrate in. And here we need to set the parameters. We close the stop valve and set the flow rate to 100 SSM to vent the chamber. Please remember the chamber lid cannot be lifted if the chamber is cold. Only vent when system is hot. As I said before, that the temperature of the chamber, outer heater or center heater should be set to at least 80 degrees. Cause at the lower temperature, the lid will not open. So leave the system vented for as short as the time as possible. So now we can see from the graph that the pressure in chamber has been higher. So we need to wait for the lid to rise slightly from the chamber. It will take a few minutes. So do not transfer the gauge pressure. Please be patient. It is important to wait for the chamber to reach the atmospheric pressure to preserve the integrity of the O-ring, because the O-ring in chamber is very expensive, so we cannot force the lid to open. It should be open without any effort. Okay, 10 minutes passed, and now we can see the chamber can be easily lifted. Move away the hood and open the chamber to put the substrate in. It's gonna be better for you to place the sample in the center of the chamber. Close the lid and cover the hood again. Open the stop valve to pump down the chamber. We can set the flow rate to 10 and make sure the base pressure be less than 0.5 torr before deposition. At the same time, the deposition temperature in chamber can be set according to your recipe. You should make sure all the heaters are set to the designed temperatures before deposition, and also need to check the gauge pressure is less than 0.5 torr and the value is stable for several minutes. And also confirm that your recipe has been loaded from the corresponding folder. Now open the machine case and open the mechanical valve of 1 and 2, which is a water and the trimethyluminium respectively. Click Start Run in the run cycle area, and you can see the pulses in the pressure plot area. That means the deposition is starting. During the working time, you always need to confirm everything is going well. If the precursor is running out and the pulses disappear during the running cycles, you need to contact the group members in Dalton's group and do not attempt to change precursors by yourself. After the run is over, vent the system by set flow rate to 100 SSM and remove your sample. and then clean the whole chamber slightly, including the bottom and the top of the lid, with IPA solution by less tissue, so that we can remove out some unreacted precursors stick on the surface of the chamber. And now close the lid and pump down with the flow rate set to 10 SCM. In case of other recipe used for different sauce, we need to completely remove the residue sauce in LD wave. So close the corresponding wave and run the system for 10 cycles with the same recipe until there's no pumps in plot area. And during this process, we need to keep the water source open as the reactant. Finally, close the water wave. Set the outer and the center chamber heater back to 120 centigrade. Check the gauge pressure. It's always less than 0.5 torr. And then write down your process on the logbook.